Hello friends and welcome to our YouTube channel Electronic Katha. In this video we'll discuss about how to determine or how to check periodicity of discrete time signals. Now in this case first we'll discuss about important condition to check the periodicity and then we'll see the examples. Now as far as the definition is considered, a discrete time signal is said to be periodic in nature if it repeats itself after certain interval of time. That means mathematically we can represent it as x of n should be equal to x of n plus capital N, where capital N simply indicates number of samples with which the signal is repetitive. That means if I add those number of samples, the signal shows the repetitivity, then only the signal is going to be periodic in nature. For example, if you want to draw such kind of signal which is periodic in nature, let us assume that we have a 4 sample signal 1, 2, 3 and this is 4. They are being defined for 0, 1, 2, 3 interval having amplitudes 1, 2, 3 and 4. Now if you see this particular signal, we can see that this is non-periodic in nature because after 3 it is not repeating and after 0 it is not repeating. But if I add equal number of samples to the right and left, it may be repetitive. Here we are having 4 samples, that is n is equals to 4. Now if I add 4 samples to the right and left with the same amplitude, let 1, 2, this is 3 and this is 4. 4, 5, 6, 7, 1, 2, 3 and 4. Now it shows the repetitivity. That means if I add that much number of sample, it is going to be periodic in nature. So based on this condition, now we'll find its important condition. So let us consider we are having a sequence xn as a cos omega n plus phi. This is the standard way of representing any signal with amplitude, with frequency and with phase. Then I can obtain this x of n plus n by replacing small n with small n plus capital N in above equation. We'll get a cos this omega as it is, this is n plus capital N plus phi. So we can write this is a cos omega small n omega capital N plus phi. Let this is our first equation. Now we'll convert this omega in terms of frequency component, that is 2 pi f. So this is a cos 2 pi f small n 2 pi f capital N plus phi, and this is also a cos 2 pi f small n plus phi. Now in order to hold equation number 2, these two signals should be same. That means this condition will write equation 1 can be satisfied if and only if a cos 2 pi fn plus phase should be equals to a cos 2 pi f small n plus 2 pi f capital N plus phi. If this is satisfied, then only we can say that signal is periodic in nature. Now the condition is what? Amplitude is same, shape is same, 2 pi fn 2 pi fn is same, and so phase is same. But here this parameter 2 pi fn and here we don't have anything. That means if I equate this to another term as 2 pi k, and if it is equals to 2 pi fn, then only this equation is going to be satisfied. That means there should be another integer as k that will equate these two equations. So we can write 2 pi k should be equals to this term. So based on that, this 2 pi will get cancelled and we'll get this frequency component f is equals to ratio of k by n, where k is any integer which can have any value, that is an integer. And here the important point is what? Number of samples with which the signal is going to be repetitive. That means in order to check the periodicity, we have to determine frequency of the given signal, and if they are in the form of k by n, the signal is going to be repetitive in nature. Now let us see some examples on this, and by that we'll try to find its periodicity also. Let the first example is x of n is given in the form of cos. So first we'll compare this with standard form as I'm writing it here, compare with cos 2 pi fn. or cos omega n. So if we equate these two terms, we can write 2 pi f is equal to 0.01 pi. Even if you did ignore pi, it will be fine. So this pi will get cancelled, and now we are left with f as 0.01 upon 2. Now this is 0.01, that means this should be 10 to the power minus 2 divided by 2. If I shift 10 to the power 2 to the denominator, we can get 1 by 200. Now I have to equate this with the standard form as k upon n. Now you can see they are in rational. They are nothing but a ratio of both integers 1 by 200, and therefore if I equate this term, we can write number of samples are 200. That means the given signal is repeating itself after every 200 samples. So in this way one can determine the number of samples and check the periodicity. Now let us come to the next question. X of n is equals to sine n by 8 minus pi is given. Now in this case, the given signal is in the form of a sine frequency plus phase omega n plus phi. So we'll compare this with standard form of this equation, that is compare with sine 2 pi fn plus phi. Now here we have to determine only frequency component, so we can ignore the phase, and by comparing these two terms we can write 2 pi f is equals to 1 upon 8. So we'll get f is equals to 1 upon 2 pi into 8 will be 16 pi. Now this is 1 upon 16 pi. So again we have to check whether the given is in rational or irrational form. So 16 pi in the denominator, 16 into 3.14 definitely uses fractional, and if it is in fractional form, we can say that this is irrational, or the number is irrational. And if it is irrational, we have seen in previous lecture important conditions, this is going to be non-periodic in nature. So the important condition should be what? This should be in the form of k by n with rationality. So in this way we assumed, or we have determined, this is going to be a non-periodic signal. Now let us see another type of example, that is multiplication of two signals. Now in case of continuous time signals, we have seen addition of two different signals. Now we'll see multiplication of signals. So the process will be same. First we'll determine frequency of cos n by 8, and then we'll determine frequency of cos n pi by 8. So let us consider x1n is equal to cos n by 8. We'll compare this with standard form as cos 2 pi f1 n. Because this is x1n, we'll assume the frequency component as f1. So if I compare these two terms, we can write 2 pi f1 is equals to 1 upon 8. So we'll get f1 is equals to 1 by 16 pi. So the first frequency component we got 1 upon 16 pi. Now we'll come across the second one, that is x2n is equals to cos n pi by 8. Again we'll compare this with cos 2 pi f2n. So we'll get 2 pi f2 is equals to pi divided by 8. Now this pi will get cancelled, and we'll get f2 is equals to 1 by 16. Now we have to multiply these two frequency component, so that we'll get the entire frequency component as f is equals to f1 into f2 is 1 by 16 pi into 16. Now again, if you see in the denominator, we are getting 16 into 16, that is 16 square. It may be 256 into pi. So definitely denominator is going to be fractional, and if it is fractional, our frequency component is in irrational form, and if it is in irrational form, signal is going to be non-periodic in nature, and hence we can write directly as frequency is in irrational form, signal is aperiodic in nature. So in this way one can assume whether the signals are periodic or non-periodic in nature. So you can expect such kinds of questions in case of continuous time signals or discrete time signals. Only either the values are going to be changed and the shape is going to be same, maybe cos, sine, or maybe multiplication of these two signals. If you are liking our videos and if you are getting all those concepts, please like to our videos, comment on it, as well as share our videos, as well as try to subscribe. Thank you.